Hello, students. Welcome to Unit 1 Note section, Lesson 4. In this one, we are focusing in on IXL A8. This is the last one for the unit, solving systems of linear equations. This one, for this lesson, there's a few different types of methods. The first one is solving a system of linear equations by let's see, we can do it by graphing, by substitution. Oh, I'm going to run out of room. You know what? Let me move it down here. Graphing. Oh, let me start over. Graphing, by substitution, and also by elimination. So with this, we have a few different ways of solving, and really, I like students to think critically, creatively about which one's best. The software doesn't necessarily let you do that. It's going to tell you it wants you to solve it by graphing or by another method. Well, it doesn't really specify substitution or elimination, but you have kind of the choice of picking which one of those you would like. And don't forget, slope is rise over run. So when we're looking at our equations and we go to graph them, we're going to be looking at them using slope, which is rise over run. So here's the first question. Solve the system of equation by graphing. First graph the equation and then type the solution. So what I did was I took these two lines, I've already graphed them for you so you can see an example. The first line, y equals x plus 4, has a slope. Remember, so this is something we also have to remember. Y equals mx plus b, where m is our slope and b is our y-intercept. And x and y are any random locations that we want. So in this one, it's y equals 1. There's 1 x's, so it's implied that the slope is 1. And the y-intercept for this one is 4. So let's look at what that looks like. We're going to start at 4, and we are going to go up 1 and over 1, because our slope is rise over run. It's 1. So I can write this as 1 over 1 if I wanted. It's the same thing as just 1. So up 1, over 1, up 1, over 1, up 1, over 1. And you notice that we read the graph from left to right. And we do rise first, over run second. And so this is an example here. Let me pick a different color because this is kind of hard to see. Let me do rise over run. I'm just going to label it again real quick. Okay. So here's my rise over my run. And we read from left to right. All right. That's the first one. The second one, notice there are no x's. So there are no x's. So in this case, the slope is 0. And the y-intercept for this other one is -1, because it's just a number. It's a standalone number. So the standalone number is just -1. So here we have -1 for my y-intercept. I probably shouldn't use blue on blue. Okay, and a slope of 0. Notice it's not going up anything, it's just going over. Okay. So we're reading from left to right. It goes up 0, the rise is 0, and the run is forever. Here's your run. Forever it's rising 0 and running over forever. So that's graphing it. Now on the software, you'll be able to, I'm just going to show you real quick on the software. Like for this one, you start at 3. All you do is you click at 3. Then you go down 1 over 1, and you just adjust it. So it's pretty cool. So, it happens pretty quick. Where this other one is y equals 5. So this one, I'm going to click the other box here. See how I selected it? You can switch back and forth. And y equals 5 happens right here. Okay? So I'm just trying to show you, I don't want you to follow along with this example. I just want you to see that just by clicking at the bottom, you can change which one you want to work with. And then you just click where you want it to go. Okay? And when you're done graphing it, then you have to answer the question, which is where's the solution? So this is what we call an ordered pair. This is an ordered pair. An ordered pair of coordinates is the location x and y where this where the function intersects, where the two lines intersect. So we're going to go and find out where they intersect, which appears to be right here, which we read as x comma y, which we read as -5. Think about what we're doing. Here's the origin. 1, 2, 3, 4, 5, and then down 1. So it's -5 on the x-coordinate plane, -1 on the y-axis. So in this coordinate plane, we go back 5, down 1, and it's 5 comma -1. That is our ordered pair. So the answer to all of this is -5, -1. And that's it. It was just looking for the location where this intersects. And here's what's really cool. We actually already had y was -1. So we already kind of knew it's always going to be -1 no matter what. The question is, where would the other line intersect it to get that -1? All right. The next question. Ooh, this one's a little bit more difficult. We're going to have to rearrange some of this. This is going to be one of your most difficult lessons, I think. But it's okay, you got this. So let's rearrange this. So we have -6 equals x plus 2y. I don't like the way or the form that that's in. So the first thing I'm going to do is move y over to the other side. So I'm going to move this over by taking 2y away from both sides. And I'm going to get -2y minus 6 is now on the left-hand side, and only x is on the right-hand side. The next thing I need to do is add 6 to both sides to move 6 over, because now I want to move all of my y's over to the left and all of everything else over to the right, because don't forget, I still want this to be in slope-intercept form, which is y equals mx plus b. I want my y's on the left side. I want everything else on the right. So after doing this, I'm going to get -2y on the left, and on the right, I'm going to get x plus 6. It's starting to look a little bit better. Looks like I have one more step that I have to do, which is going to be to divide both sides by -2. And what happens with this is we get y. This is 1x, so it becomes 1 over, well, in this case, -1 over 2x. So I had 1x to begin with. Oops, I don't know what is happening. I had 1x to begin with, and I divided by -2, which means I now have -1 over 2x. And this last one, 6, here, let me write it out this way. I'm going to do -2 and -2. Okay. The last one is going to be -6 over 2 over -6, 6 over -2, which is going to be -3. 6 divided by 2 is 3, but it divided by -2 makes it a -3. That was a lot of work. We're going to work on these in class, so I'm going to answer any questions you have. Just your goal today is to watch that video, do a couple practice ones, and when you get to the difficult ones, we'll work together in class on this or on Google Meet, so I can help you rearrange these the way they're supposed to be, okay? If you understand this, that's great. You get to rearrange it. You can go right ahead and graph this. And you can always check your work on Desmos too. I'll show you how to do that in a little bit. Now this next one, we are going to do this as well. Let's see. I'm going to do this other one. Where can I do this one? Okay, I'm going to put a little star right here. I'm going to rearrange this one now over here. So what do I have? X plus y plus 1. X plus y plus 1 equals 0. What I'm going to want to do is I'm going to want to move x over. And so now I have y plus 1 equals -x. And then the second thing I'm going to do is take 1 away from both sides as well. And I'm going to get y equals -x minus 1. So again, I'm just moving everything over, putting it in a really, in a nice form that I can use to graph it. And then I'm going to graph it. So here is my new equation. I'll do this one in orange. Okay. And this other one, I'm going to change the color to gray so that I don't have overlapping colors. And in gray, let me change this to gray. I'm going to graph this one. Okay. So let me graph the one in orange first. My y-intercept is -3, and I'm going to go down 1 over 2. So I'm going to start at -3, and I'm going to go down 1 over 2. Down 1 over 2. So I'm going to put it right here. And I'm going to now graph, I'm going to have to zoom out here. Bear with me. I'm going to try my best to graph a line. Whoops. It wasn't too bad. I mean, it's not perfect. Let me see if I can move this. That's a little bit better. Okay, so that's my line. The software will do this for you. All right. And the next one I'm going to do in gray, which is -x minus 1. So I'm going to start at -1. And this one goes down 1. So it starts at -1. It goes down 1 over 1 because that's a -1. It's assumed it's a -1. So my next coordinate is going to go down 1 over 1, which is right here. And now I'm going to try to do my best to do a line through here. Let's see if that will, yep. And now I'm just going to tap it and move it. Oh, that wasn't that bad. Oh, that was bad. Okay, let's try this again. Let's try to move this. There we go. And it looks like there's an intersection right here of 4, don't forget 4, comma, -5. So 4, comma, -5. And that's the answer for this one. 4, comma, -5. All right. This one took a little time. It was a little bit difficult. We'll do a lot of practice in class, and we'll make sure you get through it. Okay? All right, I'm going to take a brief pause to grab a drink of water, and I will be right back. Hello, students. Welcome back. So it looks like the question we did before was a little bit more difficult. That was actually much more difficult. Hopefully, this is later on in your IXL experience with this lesson. This one does look a little bit easier, so let's definitely tackle this one now. Again, just one more example. We're going to be doing this in class. We'll help you. We'll get you there. But, do your best while you're on IXL with it and to understand the lesson. So, looks like we're going to have to move this one around, but this one looks like it's okay. So, actually, let me change the color here. This one's okay. So in purple, I'll graph that one. And then I will, whatever color I end with will be what I graph the second line, or in this case, the first line on the graph with. So here we have x minus y equals 2. I'm going to move x over because I want to get y by itself. So here we have negative y equals negative x plus 2. So here you have your 2 that stays. Your negative x is going to stay on the right side now. It goes away from the left side. All right. And then I'm going to, oh, look, it looks like I have a negative y, and I want that to be a positive. So we have two options. I can multiply both sides by -1, or I can divide both sides by -1. So I'm going to first divide by -1. That works for me. All right. And I will get a positive y, a positive x, and now a -2. And so this will be the graph that I'm actually going to graph. Sorry, the line that I'm going to be graphing. That's weird. Not what I want, not what I want. Nope, nope, nope. Fourth time is a charm. Okay. So in blue, I'm going to be graphing x minus 2. So in this case, we have the y-intercept is 2. I'm sorry, -2. And the slope is 1. So we're going to start at -2, and we are going to go down 1 over 1. And I'm sorry, we are starting at -2 and going up 1 over 1. My apologies. And now I'm going to graph that. All right. I have the tools to be able to slide it around, so a little bit easier for me. And that's what we have in blue. Oh, that's weird. It doesn't match the blue down here. That's okay. Maybe I should be consistent with the lines. I could leave it orange, I guess. Let me change it to orange. Because I use the worst color possible because of these tabs down at the bottom here. So that will be, so this other one I'll make blue. Okay. And I will just change, you know what, I'll change this to orange. Can't really see this now. Okay. Let's go with light purple. Okay. So the one in blue is going to start at 5 and is going to go down 5 over 2. So it's down 5 over 2 right there. So I'm going to go right there, and I'm going to connect. And I'm just going to move it around just a little bit. Let's see. Whoa. It's not what I wanted. That's good enough. That looks pretty good. I'm going to throw arrows on it because it's a line, and it goes on forever. All right, and it looks like the point of intersection is 2, 0. And that is it. It goes over 2 from the origin and up 0, so 2, 0. All right, so that's the graphing ones. Let's do, here's going to be a quick example. So I'm just gonna, let's just do one real quick. So x plus y equals 2. I'm going to do the math in my head. It's going to go through 2 and have a slope of -1. So that's what I'm going to graph. It's going to look like that. And then this other one, I'm going to move x over. I'm going to divide by 4. Looks like I'm going to have a y-intercept of -1. And I believe it's going to be -1/4. So it's going to go down 1/4. So quickly you'll be able to graph these, and then you're just, you are going to then type in the coordinate, which is 4, -2. Okay, and that's the work for it. You're gonna have to do the work on a separate sheet of paper. Let's hit submit, and there we are. All right, the rest of them are solving by substitution or elimination. So in this one right here, I gave you a problem that you already know what x is. X is 5, right? So x here is 5. That's already going to be the answer to this solution set. And what I did was I set it up really nice where you can use substitution. Wherever I see an x, I can now evaluate it at a 5. So I'm going to do 9 times 5 minus 9 times y equals -9. I'm rewriting this equation. I'm rewriting the bottom equation. But wherever I see an x, I replace it with 5 because they're equivalent. This is called substitution. So this one is substitution. And I'm just going to do the math out. Okay, so 9 times 5 is 45. And I rewrite the rest of it. I take 45 away from both sides. And I get -9y on the left-hand side, and on the right, 45, 54, I have -54. And the last thing I'm going to do is divide by -9, and I get y is equal to 6. 6 times 9 is 54. And I know I went fast, so I'm going to explain what I did. I was looking for what x and y have to be for it to work out. They already gave me my x, so I immediately put it in because I know that x has to be 5. And then I used 5 and I evaluated it and I solved for the y variable, and the y variable is 6. So if you think about this, if I put in 5, if I actually evaluate this, I'll get 9 times 5 is 45, 9 times 6 is 54, and 45 minus 54 is actually -9. So I'm just finding what combination x and y work. If this was on a graph, you could graph both of these, and you would still get the intersection of 5, 6. All right. Let me make sure that these are, I didn't mess these up in terms of color. No, we'll leave those colors. That's fine. All right, next one. This one is going to be, I think the easiest way to do this is elimination, and I'll explain why in a second. So with elimination, you're actually, instead of substituting in, you don't really do that till the end after you solve for a variable. So I'm going to rewrite both of these. And here's why I thought eliminate. Take a look at these two numbers, 3 and 3. One is a positive 3y, one is a negative 3y. If I do this crazy thing and I add them together, think about what happens. What is 3 minus 3? Well, it's 0. So I can write 0 here, but I actually don't need it because it's implied that it's 0. So that goes away. When I add negative 10 and negative 3, I get negative 13x. And when I do 6 minus 19, I get negative 13. And very, very, very quickly, I find that I can divide this by negative 13, and I see that x is equal to 1. And I have found half of my answer, x is 1. And it was quick because I didn't have to move anything around. I didn't have to divide anything right away. I didn't have to substitute in. I didn't have to graph it. It would be very complicated to move everything around and graph it and do all of that work. But quickly here, I see that I get 1 as my answer for x. So now all I need to do now is take another one of these problems. So let's take this one. Take one of these lines. It doesn't matter which one I take, but I can now use what I know, which is x is 1, and I get to use substitution and substitute in for that 1. So negative 3 times 1 plus 3y equals 6. Now this is not substitution. I said we're doing this by elimination. And we eliminated. But now there's nothing to eliminate unless we switch over and try to eliminate our x's, and then we'll solve for y. But at this point, we're using a combination of elimination and then substitution, but we call it elimination because that's the first thing we did. We focus in on eliminating the 3's. So after substituting this in, I'm going to get negative 3 plus 3y equals 6. I'm going to add 3 to both sides, and I'm going to get 3y equals 9. And now 3y equals 9. I'm going to divide both sides by 3, and y equals 3. And so I now have the answer of my ordered pair, which is 1, 3. And that was elimination. You guys have already done this before, I think. But this is hopefully a good review for it. I'm going to be consistent, elimination, substitution. All right, the next one, you know what? I'm seeing immediately elimination again. Check that out, 5 and 5. But I want to be careful, right? Because 5 and 5 is 10. It's not 0. What I need to first do is I think I'm going to rewrite this and eliminate, but I'm going to rewrite this one like this. I'm going to keep it exactly the way it is. And this other one, I'm going to change it. I don't want 5 plus 5. That is 10. I want 5 minus 5, which is 0, which would eliminate the 5's. Well, how do I make a positive and negative? Oh, you can multiply it by 1. Negative 1, right? I can't just multiply one thing by negative 1. I have to multiply everything by negative 1. Okay, so I'm going to do negative 1 times all of that. And I'm going to rewrite this line. So negative 1 times negative 2 is a positive 2. Negative 1 times negative 5 is a is a negative 5. So negative 5y. And a negative 1 times 6 is, sorry, a negative 1 times 16 is a negative 16. And now I'm ready to eliminate. So add them together. I get 5x equals 1 minus 16 is negative 15. And I now will divide by 5, and I get x equals negative 3. And again, it goes where my x coordinate goes. Be careful. If I solve for y, it wouldn't go here. It would go here. But this is my x. And now I can take any line and I can solve for my y. So what I think I'm going to do is I'm going to take the line 1 because I didn't do anything to it. I didn't change it. 3x, right? Well, you know what? Let me rewrite it. 3x plus 5y equals 1. So I'm going to take this number, I'm running out of colors, wow. I use that one. I pretty much use everything. Okay, I didn't use this one. Negative 3 is going to go in for here. You know what? Let me erase this. Okay, so now it's a little bit more organized. So 3 times negative 3 plus 5y equals 1. So negative 9 plus 5y equals 1. Going to add 9, and I get 5y equals 10. And my last step is divide both sides by 5, y equals 2. I know I went fast again. Again, we're going to do this work in class. I'm just trying to show you that we're doing a combination of substitution and elimination for this. All right. And that would be the answer to that one. And it looks like there are 2 more. Yep, both of these involve a little bit more work. So I'm going to model them quickly. Again, we'll help you in class. Just try to follow along. I'm looking at this right here, and I want to eliminate them because I like to eliminate. I find it easier. So I have 1x and I have negative 2 x's. So I need to make this a 2, and that would actually make my life pretty easy. Or it looks like I have 4 here and I have 8 here, and if I made one of these a positive 8, that would also work out pretty well. But you know what? Here's what I'm going to do. I'm going to multiply this by 2, and watch what happens. So here I have negative 2x minus 4y equals 4. I'm just rewriting it. And in this one, I have 2x minus 16y equals negative 24. And when I add these together, oh, look at that. We eliminate this, and I get negative 20y. And here I get negative 20. Oh, that was really nice. So now I'm going to divide both sides by negative 20 to solve for my y. And I get y equals 1. And that looks pretty good. So y is 1. And what I'm going to do now is, let's pick, what line do I want to, you know what, let's do this one because this one looks a little bit easier. I'm going to take the original here, x minus 8y, and I'm going to use this one, equals negative 12. And I'm going to take 1 and put it in for y. So I get x minus 8 times 1 equals negative 12. And then it's going to be x, 8 times 1 is 8. So it's negative 8. I'm going to add 8 to both sides. and I'm going to get x equals negative 4. Be careful, 8 minus 12 is negative 4, or negative 12 plus 8 is negative 4. So I'm going to have negative 4 as the answer for that. Okay, let me check my work real quick. That one looks good. 8 minus 4 is 4. Yeah. So I checked the work in my head. That looks pretty good. All right, let me put a box. And for the answer, or half of the answer. All right, the last one. It looks like the only way to fix this one, to make it the easiest, I'm thinking that 9 and 6, I would have to multiply this by, what, 2 and this by 3? I could do that. I can multiply this by negative 8. You know what? Let's get crazy for this last one. Let's go all out. I'm going to multiply this line by 2. Just watch. And then I'm going to multiply this one by 3. So multiplying both of them, it's going to be crazy. Here we're going to have 18x plus 2y equals negative 24. And for this one, I'm going to have 612 negative 18x plus 24y equals 18 times 3. I just want to make sure I get that right. 18 times 3 is 54, yeah. Okay, and 54. Wait a minute. Let me just make sure I did this right. 9 times 2 is 18. 2 times 1 is 2. 2 times negative 12 is negative 24. 3 times negative 6 is negative 18. 8 times 3 is 24. And 18 times 3 is 54. Why does this look strange? 9, 18, 2y, negative 24, 6, 12, 18, 8, 16, 24, and, oh, it's negative 54. There we go. Okay, be careful. See, 3 times negative 18, it's a negative, and so it's negative 54. I did the math in my head, and one of the numbers weren't working, and I realized why. Okay, so I'm going to add these together. So the 18s will go away. 18 minus 18 is 0. 24 plus 2 is 26y. And then we have negative 54, negative 24. That's negative 78. All right. Divide both sides by 26. 75, 76, 77, 78. So y equals negative 3. It's a whole number, negative 3. We don't always need a whole number, but in these problems, normally they always equate to a whole number. So I know I'm on the right track, normally, if I get that. That doesn't mean it's always correct. Okay? And so now I'm going to take anything. It doesn't really matter. You know what? I'm going to take line 1. I tend to take positive lines. I'm not sure why, but just easier for me, I guess. I'm going to take 9x plus y equals 12. Oh, no, I'm sorry, it's negative 12. I'm going to take that first line. Okay, all I did was rewrite it. And I'm going to now take y and substitute it in. And so I picked one that was, a little bit easier because it's, it didn't really involve multiplying. This 8y would have involved multiplying. So here I have 9x minus 3 equals negative 12. And I'm going to add 3 and add 3. And I get 9x equals negative 9. And lastly, what do I got? I'll use purple. I divide by 9. I get x equals -1. All right. And that's it. We're going to help you. This is a tough one, okay? I put right at the top of this one, and what was this, our last one? I put, uh, oh, I didn't put a little thing. Okay, I put a do not forget, slopers rise over run. I'm going to put a little sticker on this one, and let's see. Do your best. You're going to do your best with this one. Well, where's my stickers? You got this. Don't forget, great job. Wait, it's not here. How about this one? You got this. We'll help you in class, but you got this. All right? All right, so good luck with A8.